Good morning. We're going to be continuing to work on the absolute value functions, in this case transformations. And here we have Explore 2, predicting the effects of parameters on the graphs of absolute value functions. And we have these two formats. This is a general transformation function like this. And when we apply specifically to the absolute value function, this is what it looks like. And so if we have like g of x equals, what I like to do is I like to take this a and 1 over b and just consolidate that as a single outside type of a factor. So this is what I like to, you see what I'm talking about? Distilling this as a single coefficient on the outside. I just think it keeps your life simpler. So we're going to try to do that whenever possible. And then what do these other things do that we talk about? What does this A do?
It makes it.
Stretches it?
Yeah, stretches or compresses, right? So we'll say vertically stretch or compress. Let's talk about vertical.
And you reflect it off the axis if it's negative.
Yeah, that's right, okay. So we have Jose today, our overachiever, right?
I think, I have a question, but I think I'm gonna sound dumb.
Okay, that's fine, but what it is, a lot of times, the good questions is the one that goes unasked because they're embarrassed by it. But don't be embarrassed. What is your question?
Why do you, sometimes you use g of x and sometimes you use f of x?
Okay, that's a real good question. Look at what happens is that it sort of gets you ready for things. Kind of the standard one is f of x, and the reason it's standard is that I think f is like the first letter in function maybe, but because you can possibly have more than one, is that here sometimes what you'll have is one function will be f of x, and if you have another function on the same graph or comparing with f of x, you introduce the other letter to notify the audience that, hey, this is a different function, or h of x. But the reason sometimes I put different letters up here is to get you ready for possibly seeing that. And that way, when you see g of x instead of f of x, you're not all freaked out about it. So it's just a matter of being, so gradually I might introduce things a little bit of a different slant, or the textbook might in this case, just to sort of open your mind to the possibility of that. But like f and g and h are kind of the standard ones, and A, B, and C are usually used for coefficients. So they're just in points like A, B, and C would be like points in the triangle. So or capital A, capital B, capital C. So different types of notation that are more or less standard, but we don't have to restrict ourselves to those. So it's just encouraging to be a little bit open-minded about the possibilities. And so that's actually a good question. Okay, and then who else said, oh, it was Jose who also said, if you have negative sign reflects about x-axis, right? And then h does what? Okay, Lexi says h shifts left to right. And then k shifts up and down. Thank you, Siggy. And so what you're left with is the vertex. Vertex is the coordinate pair h comma K. All right, so you can always go back to that and figure things out with that. All right, so thank you. Let me make sure what we're seeing here. I want to make sure we get this on the, get everything on there. Okay, I think that's better. Yeah, I want to make sure everything gets on there. All right. Okay, questions? Any other questions about that? Atlee, that was a good question. Anything else?
Thank you.
Sure. There's Marcus, okay. Okay. All right. And then, here I think we already talked about this briefly the other time, didn't we? Okay, this graph of g of x equals absolute value of x plus 6 will be the graph of the parent function. And here's a good example, Atlee, about why we have a g of x and f of x in this instance. Because the g of x is this one here, and we're comparing it to this f of x here.
Yeah.
So it's just helpful with notation sometimes. All right, so this one here is going to be this one translated which way? Up 6 units, right? And then this one here, the minus 4, is going to be translated down 4 units. Okay, and then this one here, g of x equals x minus 3 and quantity x minus 3, absolute value of quantity x minus 3. Is this graph translated? Okay, so that's counterintuitive, and if you put this in your calculator, you can see that for yourself, right?
Yeah.
And I want to go ahead and get that calculator up here, just in case we need it. There we go, it'll come up. Close. So come over here, clear, 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 and then come up here, and how do we get the absolute value? Second, there are different ways to do it. I like to press second catalog enter, and here we can put x minus 3, and then we'll see which way the thing shifts. So yeah, x minus 3 here will shift the vertex to the right 3 units. Again, as we had in our notes earlier, I call this a counterintuitive shift. And then this one is going to shift, this x plus 5 is going to shift which way? Left 5 units. I want to introduce something else, and I think Atlee got me thinking about this, is one thing I say, the graph of g of x equals the absolute value of quantity x plus 5. That's how I would say that verbally. Let me say it again. The graph of g subscript 2 of x is the absolute value of quantity x plus 5. Okay. Now, you'll hear me a lot of times say that word quantity. You've already heard me say it a lot. What does the word quantity mean?
Amount.
It means amount, okay? But in the context of the way I've been saying it, what does quantity doesn't mean exactly amount? Can you figure out what it means? No. Here's what it means. When I say quantity x minus x plus 5 in this instance. When I say the word quantity, what I'm doing is I'm verbally putting a open and closed parentheses. What it tells you, when I say quantity, it means consider the next two things I say to be in parentheses. So I say quantity, the absolute value of quantity x plus 5, I'm saying the absolute value of quantity, and I'm saying x plus 5 that you consider in there. If I don't say that, if I say the absolute value of x plus 5, I would say absolute value, that would be absolute value of x plus 5. When I say quantity, that enables somebody who hears me to still, without me writing it, visualize what it is. And that's something that some teachers do that, some don't. It's technically it has, you see the utility of it? Okay, so it's kind of get used to it, because it's the way that, and where did I pick it up from? Where do you think I learned that from?
Your teacher.
Okay, I learned it from when I started making YouTube videos, and I watched other teachers, and I heard teachers say that, and I said, okay, yeah, this guy says that, and that's right. So I learned from my colleagues who are fellow sister video makers that what they do, and so that's just something I've learned over the years. So that way, if you just hear me, Atlee, in the video without seeing me, you can visualize what I'm writing sometimes, even with that. So that's what I do. Probably most teachers aren't going to do that, but it's just something I've learned. Okay. Here we have the graph of g of x equals 1/4 absolute value of x will be this graph compressed, and how would we say that? Compressed vertically by what? By what is this 1/4? What do we call that?
Quarter.
Yeah, it's a quarter. It's quarter or 0.25. But what do we call it in the anatomy of a function of arithmetic? What do we call this 1/4 out here? We call it it's a fraction. But what does this 1/4 do? What is it performing?
It makes it go up a vertical stretch or compression.
Okay, and we call that, and it vertically stretches or compresses because it is a what? Starts with an F.
It's
Function.
No,
factoration.
it's a factor. It is a factor. By a factor of 1/4. That's the word I was looking for. Factor of 1/4 or 0.25. And then it says, here we have, and I want somebody, this next one, to answer this. The graph of g2 of x equals -3, absolute value of x will be the graph of fx equals absolute value of x stretched what?
Vertically.
Vertically
By a factor of 1/4. Oh, that's negative?
by
I need to get my contact.
a factor
You say
of 3 and reflected
over the x-axis.
over or about the x-axis.
About.
And but over or about are kind of synonymous words. So over or about the x-axis. And sometimes a lot of people will use the word flipped, okay, which instead of reflected, which is not as conventionally acceptable as reflected, but if you, in your own words, write the word flip instead of that, I know what that means. Okay, I know that conceptually you understand what is going on. And then as far as what they look like here, what you have is you got to look at this 1/4. What else could we call this thing besides a factor, besides a fraction, besides a number? What else could we call this thing? What role does this play in the language of linear functions? It's like somebody said it very hesitatingly said slope. Somebody, who said that? Somebody back here. Jose, okay, yeah. So it's like a slope, right? It really is like a slope, but it's not and so this slope being 1/4, you go like up 1 and over, that's up 2, right? Mm-hmm. Yeah, so I'm gonna go up 1 and over 4, so the thing's gonna look like this. And then the other way, what you have to do for absolute value function, you have to do the other way, the opposite direction too. So the thing's going to look like this.
Yeah.
And again, you could test this out in the calculator to see that that's the case. And then for this one here, this -3x, well again, so this -3 is like a slope. So you can go down 3 and over 1. That's going to be like down 6 and over 2. I'm just trying to graphically get it right. So this one's going to be like this. Something like this. Okay, that'll be this one here. And this one here will be this one up here. And what we're trying to do here is to be able to do these with a calculator and then use your calculator to check. Okay, do you have any questions about these? Okay, good. You guys are making some good inferences. And let me erase this again. Okay. Now, this one here, they're trying to say stretched horizontally, but what you can do with this 1/4 is you can actually, there's nothing that keeps you from pulling it outside. Now, but this one here is different when you have the negative sign in here, because what does absolute value do? Makes everything positive. So what you'll do when you actually graph this, is this thing going to be reflected? Put this in a calculator and see what you see. I don't think you're going to see like this one here. You're probably going to see just, so that's just something to watch out for. When you see a negative sign inside the bracket, just watch out for that. So we go absolute value, -4x. Does it change everything positive? Yeah. See? So just watch out for that. So you could pull the 4, this 4, yeah, this 4 can be taken outside, but to translate this, you can put the 4 out here, but when you get rid of that negative sign, this is what the thing is going to look like right here, because the negative sign is going to be positivized by taking it outside, or made positive. So it's not going to be reflected about the x-axis. So I don't know what the book writers meant for it to do. So stretched. So I would call this they meant to say stretched horizontally, but really this becomes a vertical compression when you put it outside. This becomes a vertical stretch when you take it out there. But they say compressed, they meant, anyway, they meant to say compressed horizontally by a factor of 1/4. I don't know how they say it, but just watch out for that. Okay, from the graphs of G1 part C, I don't want to do that. Okay, graphing absolute value function. Okay, they have this find the vertex. Use the vertex and two other points to help you graph. So here we have, we're going to graph this one right here, g of x equals 4 times the absolute value of quantity x minus 5, then minus 2. So what is for this one right here? Can everybody see that pretty well? This one right here, Haley, you see that? Okay. Okay.
Okay.
See it? Everybody see it? Okay. Now, we have this. Do you need me to write this bigger at all? Would help?
Sure. Yeah.
4. So this is 4 times quantity x minus 5. Absolute value quantity minus 2. Okay, so that we look for a vertex in this thing. So what is our vertex going to be for this?
5, 2, -2. -5.
-5,
Vertex is going to be 5, comma, -2.
Yep.
Okay, why is that?
Because it becomes positive.
Yeah, so what it is, the vertex, remember the vertex is the coordinate pair h comma k, right? And here we have, and the format is this x minus h. So if it's x minus something, that is, so it's kind of like for the x coordinate, the sign switch is one way to think of it. Okay. And then for this one here, this is straight up, this -2, it's a straight up -2. So we go to 5 comma -2. So I say, here's 5 to the right, because these are by 2, right? So 5 comma -2. So our vertex is going to be right about here. Does that make sense? Okay, and then what about what else do we have to concern ourselves with? This 4, right? So we are doing what with that 4? Vertically, who said vertically stretching? Haley, okay, good job, Haley. Yeah, vertical stretch, by a factor of 4. So we can go up 4, and since we have the grids by 2, I'll just use these grids. So 1, 2, 3, 4, and over 1. So it's quite a steep slope over here. And what else do we have to do? Do the same thing, but in the other direction, right? So it's thing's gonna come something like this. Yeah, that's not such a bad line. All right. So anybody graph that in the calculator too? You see, I just graphed the calculator, see if, so just kind of get in the habit of confirming occasionally, see how you're doing on that. All right. Everybody, G-Dog, come on now. Here, we'll start working on this thing here today. And we probably won't get all the way through it, but that's all right. Okay. Let me erase this here. Oops. Make sure I have everything else zeroed out here. Yeah, I think you can get this out of here. Yeah. All right, let's get to this right here. This is it right here, is that right?
Yeah.
Yep.
Okay, good. So it says, predict how the graph of g of x is a transformation of the graph of fx equals f value of x. Verify your prediction using the graph calculator, then sketch the graph of the function. And so you can kind of see how, so number one goes similar to what we've talked about. On number one, what's going to happen? We have vertically stretched, but first, now in this case, are we going to stretch first, or are we going to put the vertex first?
We'll do the vertex first.
You'll do the vertex first, because you don't know where it starts. So where's our vertex going to be for this? So somebody said 3, 0, right? 3, comma 0. Yeah, because if we have h, comma k, here we don't have any plus or minus anything on the outside here. So this one, in this instance, is going to be 3, comma 0. So we can go to the right 3 units here. And this 5 does what?
Go.
Up.
Oh.
Vertically stretch by a factor of 5. Okay, good. All right, yes, thank you, Haley, and anybody else who said similarly. Good work. So there we have, so thing's going to look something like this.
Yes.
And then this one's going to be 5 over that way. Then it says verify using a graphics calculator. And you did that, right?
Yeah.
Yes.
So for these exercises here, you're just basically going to draw in the sketch of the graph. And I guess you have enough resolution on the paper to basically do that, right? It's not going to come out quite as well as what I have here. Pardon me?
Never mind.
Yeah. And so go ahead and do number 2. And on number 2, are you going to locate the vertex first still? Yeah. So number 2, what are you getting for your vertex?
2, 5.
Negative 2, 5.
Oh, what?
That's because the original.
Yeah, so when you have when you have this thing h, you have h x minus h, right? Well, if you have the only way you can get positive 2 is for h to be negative 2, because then you would have x minus negative 2. And so negative 2 becomes the x coordinate for that. But so just mentally, it's like this, consider like the sign switching in there. That's how to consider that. So you have negative 2, comma 5. So I think it's going to go about right here. Is that it?
Yeah.
And then what happens? What happens with the 4? So negative. So it's going to go down 4 over 1, right? So things going to go something like this. And I don't know what you got for your your y-intercept, and then over here it's gonna go something like this. I wasn't too careful about it, but did you graph that in the calculator too?
Yeah.
Did you, is that what you saw when you graphed the calculator? Okay, good. Now this one here, when you see stuff inside like this, when you can, my recommendation is you can just take it outside the bracket here. Same with number 4. Take it outside the bracket. That's the way I would look at it. Because you can do that. Let me look ahead to 5. Yeah, that's very simple too, g of x. Okay, and then they talk about domain and range for 6 and 7. So let me go ahead and I'll just do one of these and then let you kind of work ahead on this. So here, what is going to be your vertex for 3? 6, 4, right? And then we have, so 6, 4, and then we have this 7/5, so what is that going to be? Up 7 over 5? And we kind of don't have a lot of room on the given graph to work with. But let's try that, because to the right definitely we don't have room, but that's 2, 4, 6, 7. So that'd be like 7 up, and then we're 5 to the right. Well, that's going to be 2, 4, so about there. It's going to look something like this. And then 2, 4, 5, something like this over here. And then you verify using a calculator. And one thing you can do in a calculator that's helpful, when you see these things where these are 2 apart, you can go to your calculator and switch that. Do you know how to do that? You go to your window view and you change your X scale to 2 and your Y scale to 2, and then you'll be able to come over here. Let me make sure I get this right. Yeah, it's 6, 4. So go over here. So 7/5. And you can, what you can do with this is you can just put it like they had it originally if you want to. Like this. Oops, actually it was like this. Seven-fifths. Is it x minus 6?
Yes.
Plus 4. Then you should be able to see it, I hope. Does that look right?
Yes.
Yeah. So that's 6, 4. And then if you go by ones and change the window a little bit, you can see everything. So if I make my X max 14 and go by ones, so it just kind of depends on what you're looking for. If we do that, we should be able to see the up 7 over 5, right? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. So anyway, so work ahead as much as you can on that. Are you able to do okay on this?
Yeah.
And then we'll just pick up on this tomorrow and finish working on this tomorrow, okay? Any questions? All right, thank you, class. Good comments today on function notation and several other things. Good work.